Hello, got it. Got it. Hello, assalamu alaikum. Today we will discuss about our latest Codeforces Round 10 and through type 2. So all three problem from A to C. Before I start the discussion, I think that all of you read the problem statement from your own responsibility. I will just try to show the main graphic view of this problem. So at the first time, we will discuss about the this contest first problem A buttons. So what is the main graphic view of this problem? Here in a laboratory there are many buttons that are present. The buttons number are A plus B plus C. They have total A plus B plus C number of buttons, and the buttons type are three. They have three types of buttons: A types, B types, and C types. A types of buttons only Anna can use. B types of button only Kathy can use, and C types of button both Anna and Kathy can use. They decided to play games to press the button, and this situated button is as this way, and every button can be pressed only one time. Every button can be pressed only one time. They decided to play a game with this button press. At the first time, Anna will start the moves. He will press a single button, then Kathy will take his move, and one by one they take their turn. At the last time, who cannot get their turn? He will lose the game. We have to determine that who is the winner of the game. If Anna is the winner, then we will show first, and if Kathy is the winner, we will show no. So let's try to solve some example, then this will be more clear. At first example, 9 3 and 3. First example, I think 9 3 3 is 6 6 9 2 2 8. Okay, 9 3 3. 9 3 and 3. This is the number of buttons A, types of A. This is the button types B, and this is the button type C. If we distribute this system, then system is as this way: A, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 1, 2, and 3. At the first time, Anna will take her moves. On the next time, Kathy will take her moves. So Anna, we think that Anna takes this button and take his first move, and Kathy will take her second move with this button. Then Anna will take another move, and Kathy will take another move. Anna will take his third move, and Kathy will take her third move. Anna will take his fourth move. Kathy will take her fourth move. Anna will take his fifth move. Kathy now do not find any button to press, because he cannot press Anna's button A. So in this game, Anna will be winner. So our answer is first. On the other hand, if we have pick another example, 3 5 and 2. Here A types, B types, and C types. 3 A types, 5 B types, and 2 C types, Anna and Kathy. Anna plays his first turn. Kathy plays her first turn. Anna plays his second turn. Kathy plays her second turn. Anna plays his third turn. Kathy plays his third turn. Anna plays his fourth turn. Kathy plays her fourth turn. but Anna does not find any button to press because he cannot press the button of type B. So who is the winner? Here Kathy is the winner. So our answer is second. Just pick another example, like we have 4 types of A button, 4 types of 4 number of B button, and 4 number of C button. This is our A, B and C. Just organize this way: A, B, B, C. This is Anna and this is Kathy. At the first time, Anna take his move, Kathy take her move. Anna take his second move, Kathy take her second move. Anna takes his third move, Kathy take her third move. Anna takes his fourth move, Kathy take her fourth move. Anna take his fifth move, Kathy take her fifth move. Anna take his sixth move and Kathy take her sixth move. Now Anna cannot find any button to press. So who is the winner? Kathy is the winner. Our answer is second. If we pick this same example but little bit of difference, 4, 4 and 5, that means we have total 4 number of A buttons, 4 number of B button, 4 number of B buttons, and 5 number of C buttons. 5 number of C buttons. And this is Anna, this is Kathy. This is Anna and this is Kathy. Anna take his first move, Kathy take her first move. Anna take his second move, Kathy take her second move. Anna take his third move, Kathy take her third move. Anna take his fourth move, Kathy take her fourth move. Anna take his fifth move, Kathy take her fifth move. And Anna take his sixth move, Kathy take his sixth move. Take her sixth move. Anna take his seventh move, but Kathy does not find any button to press. So who is the winner? Anna is the winner. So our answer is first. So the example we will solve, if we try to analyze the examples we will solve, then we will see a common things that if at the first example 9, 3 and 3, here the number of button A is greater than number of button B. If this type of situation is happening, then B types or Kathy need to take help from the button type C. Kathy need to take button type C, as like as B is smaller than A, so and as like as B is smaller than A, so B will finished earlier than A. Then Anna has another types of button A that is remaining, but Kathy does not have another option without press the button of type C. But if Anna can press the button type C, so he will press the button type C and decrease the chances of Kathy. Then if the situation is happen, then always our answer is first. Always our answer is first. And if we pick the second type of example, here our B is greater than A. Here A will be finished earlier, then Anna need to take the help of button C, and B has or Kathy has the remaining button of types B to press. But Kathy has not, Anna has not another option without press the button C. But if if Kathy can press the button of type C, so she will press the button type C and try to reduce the chances of Anna. Then button of type C will be finished. If C will be finished, if Anna can finish the button of type C earlier, but Kathy has another types of option, that is B, the remaining button he has, the remaining button she has. So he will be always winner. He will be Kathy will be always be winner. So here in this case our answer is second. In this case our answer is second. And what happened if both of them are equal? That means A and B are equal. Then have to check that the number of buttons C is odd or even. If the number of button C is even, then always Ketu will be winner. Why? Because A and B, if A and B is equal, so they will be finished at the same time. Then Anna have to take the first help from the button of type C. So this is 1, and Ketu will be played at second. So last, what is the last button? Last number of button is even. So Ketu can take the last move, but Anna cannot take another move of the button type C. Anna cannot take another move of button type C. Why? Because our we have total even number of buttons C. So at the same time, if the both A and B are equal, if both A and B are equal and number of buttons C is odd, then Anna will get the last odd options to press, but Kathy does not get last even option to press. So in this case, always our answer will be first, or Anna will be winner. Always our answer will be first, or Anna will be winner. So if we jump to the code, is it recorded? Yes. So this is big of one solution. At the first time, check that A is greater than B or not. If this, our answer is first, and also check that B is greater than A or not. If this, press print second, because Kathy will be winner. If both of them are same, then check that the number of buttons C is even or odd. If this is odd, then just print first, because Anna will be winner. Otherwise, Kathy will be winner. This is our solution of the first problem. Now jump to the our second problem, B, the walkway. So to discuss about the problem B, I want to discuss at the first time problem C. Yet another permutation. Sorry for some net related issue. So yet another permutation. So what is the main graphic view of this problem? What is the main graphic view of this problem? Here, to solve this problem, at the first time we have to know that what is permutation and GCD. Permutation is such kind of combinated array which has length n. If this permutation has length n, then all the number in this permutation, or all the value in the permutation, is between 1 to n. No number cannot be less than 1, and no number cannot be greater than n. And there is no duplicate number in this permutation. And what is GCD? If we have two number x and y, and they have a divisor, common divisor z, that is greater than othermost divisor they have, othermost same divisor they have. This is our GCD. And what is the main graphic view of this problem? We have a number n. We have that means we have, they given a number n, and they told us to build a permutation from 1 to n is as like as this way, so that our score is maximum. What is our score? What is our score? If we build a permutation like 1, 2, 3, 4 and so on till n, then we have to determine the GCD of any two consecutive number, every two consecutive number of the permutation we build. Every two combinated permutation, every two consecutive number we build. Then the storage, or the result, the number of GCD is stored in another storage D. The number we get, or the result of GCD we get at the every case, this will be stored in another storage D. Then we will try to pick the unique element. We will try to pick the unique element. We will pick the unique element from the D, whole D we will build. So the number of unique element we will find to we will try to determine the number of unique element from the array, or our new storage D. That is the score of our point. That is the score of our game. That is the score of our game. We have to, what is our task? Our task is to build or construct this permutation as this way, so that the score is as maximum as possible. So let's solve an example. This will be more clear to understand the problem. Guess that our n is 4. So what is our permutation? 1, such that we built a permutation like this. Then what is our new storage D? What is the GCT result? 1. What is the GCT result between 2 and 3? 1. What is the GCT result between 3 and 4? This is 1. How many unique number we have? So 1. So this is our score. But if we just shift a number, 1, 2, 4, 3. Now what is the GCT? 1. What is the GCT? 2. And what is the GCT? 1. How many unique number we have? 1. So this is our score. Sorry, 2. This is our score. This is the maximum possible answer we have. So pick another example for n is equal to 7. So if we build our permutation as this, so 1, 2, 4 and 3, 6, then the paths 5 and 7. Then what is our builded array D? 1, 2, 1, 3, 1 and 1. What is our score? 3, because we have total 3 number of unique element. If we see that 7, they have total contains 3 distinct element. Now pick another example for n is equal to 10. So what we get? 1, 2, 4, then 8, then 3, then 6, then 5 and 10. So what is our builded array D? 1, 2, 4, 1, 3, 1 and 5. Total number of distinct element present at here is 5. So this is our score. Yes, and this is the maximum between all types of permutation we have. This is the maximum answer among all the permutation we have. So what is the main observation at here? When we will get a new number from the permutation, if we have two consecutive number x and y, then y, if y is twice x in this relation, then we can create a new number x. So we can understand that every two if the permutation, we can build permutation as this way, such that every two consecutive number there are every two consecutive numbers different is, or their ratio is 2, then we can say that we can create a new number as this, x by y is equal to 2, this relation, if x and y is two consecutive number in this permutation. So if this relation is satisfied, then we can say that a new number x we can generate it. New number x we can generate it. We can build this combination as this way, x by y is equal to 3. But if we have to maximize the number of answer or maximize the number of scores, so we have to choose 2 at here, because if we pick a number as 2, then we will increase the number with ratio 2. That means we will increase the number as this way, 2, 4, 8, 16 until n is finished. Then if we pick a value of I, then we will create a relation as this way, and we will store, if the permutation has no duplicate value, so the number we can get under the range of n, we will store them in an storage. we'll store them in an storage. So in this way we will at the first time we will pick a number I from 1 to n and check that this is visited or not, this is visited or already visited or not. So another DP storage we can pick at here, this is visited or not. If not visited, then we'll pick take another storage jet. This will be run from I to n between the ratio 2 into 2 increaser. So this will take big of n time and this will take log 2 base n time. This will take log 2 base n time. So total complexity is big of n log 2 base n. Total complexity is big of n log 2 base n, which will be satisfied according to our following constraint. So if we see an example of 10, so how we can build? If we pick 1 at the first time, then we'll increase it until we can situate it between the range of n. So 1 2 4 8 because and 16 is out of the range n, so skip it. Next start from the 2 is already visited, so start from the 3. So 3 6 12 is out of range, so just skip it, Then 4 is already visited, 5 is not visited, so 5 and 10, this is under the range. 5 and 10 1 2 3 4 5 6 4 5 is already visited, 6 is already visited, 7 is not visited, so 7 14 is out of the range. 5 6 7 8 is already visited, 9 this is not visited, so pick it at, put it at here 9. So and 10 already visited, so just skip it. So what is our score? This will we can ensure that this will give the highest possible score among all the permutation. This will give the highest possible score among all the permutation, because for every case we will pick the maximum possible variation we can create. So if we jump to the solution, solution is very straightforward. Take an storage A is equal to length of n, take another DP storage to remember that which number we will visit it already, and index to store the number in our final answer array. So if dpi that means number is already visited, just continue. Otherwise run a loop from I to n with the increaser ratio 2 or into 2. So mark every time dp j is equal to true, that means j is the number in this permutation we can already visit it, and add it to our final storage. At the last time we will print the array we can build. So this is the solution of our problem C. Now another time check that is it recorded or not. Yes, this is successfully recorded. Now this is the problem B. This is little to latest Codeforces contest B is little bit of different from the regular Codeforces regular type 2 contest, because this is little most tricky than C. If the problem setter set the problem B at in place of C and problem C in place of B, then this will be I think this will be right, or this can follow the rule this can follow the regular rules of type 2, but this is different, little most of different. So start to discuss about the main graphic view of this problem. We have a school where we have total n number of benches. They are numbered from 1 to n. This is a walkway. A person is situated at the position 0. He have to pass this walkway of all the benches from 1 to n, and in between this walkway from 1 to n, there are total m number of shopkeeper they have. So they are number from S1, S2 and S3, so on. They are situated, they take their places in front of the every bench, in front of m number of benches, in front of every number of benches, in front of every number of m benches. What is our main target at here? Here definitely we have some rules. He has if suppose this is a person P, he is stand on the position 0. He has a knapsack where he has infinite number of cookies, and the shopkeeper also sell the number of cookies, Person P want to eat the cookies. Our main target is to reduce the number of cookies he can eat. This is our main target. To do this, we will generate 3 rules for him. 3 rules for this person P. And from the authority, they can also remove at most one shopkeeper. Between the path he will be visited. If he is situated in this place I, then the authority can remove a shopkeeper from the path from leftmost side to ith position. They can remove at most one shopkeeper in range. That is very fine. This is mainly I plus 1 shopkeeper runs. From leftmost side to I plus 1 shopkeeper runs. That is very fine. What is our 3 rules? If I take a snap of these 3 rules and put it at here, then this will be most clear. Just zoom it. Rule number 1. There is a cookie seller near the ith benches. Then Peter will buy a cookie from the cookie seller and eat it immediately. That means when he is situated at the bench number I, then there is a cookie seller S of I. Then he can buy a cookie from the seller and eat it immediately. Rules number 2. Peter has not yet eaten a cookie. Then Peter will take a cookie from his knapsack and eat it immediately. That means Peter is now situated at the ith position from 0th position, and between this path he will not eat a single number of cookies. So he can take a cookies from his then he will take a cookies from his storage and eat it. No need to present a shopkeeper in this ith position. He will take a knapsack from his storage and eat it. We know that he has a infinite number of storage of cookie. Storage. And at the third rules, before discuss the third rules, he will pass the 2 benches. We have to say that before pass the 2 consecutive benches I and I plus 1, he will take only 1 minute of time. To pass between 2 consecutive benches. So we can say that according to our rules 3, they will say that at least after d minutes. That means at least he have to pass the d number of benches, then these rules will be applicable. Suppose he is situated at this ith position, then the from ith position to the left sides d minus 1th benches, ith bench to left side d minus 1 benches, from the d minus 1 benches from the backward side from ith bench. We have to calculate the total d minus 1 number of benches of the backward side. If in this range he will not eat a single number of cookies, then he can take a cookie from his storage, or then he can take a cookie from his knapsack and eat it. Then he can take a cookie from his knapsack and eat it immediately. This is our rules number 3. Peter can eat a cookies between these 3 rules, and we also have an action to reduce this, mainly in for this rules 3 we will generate a new rules or we will generate a new action to remove the number of shopkeeper, to reduce this rules number 3, to reduce the eaten cookies in rules number 3. So let's solve an example, then I think this will be more clear. 6 2 2 and 2 and 5, 6 2 2 2 and 5. So this is a straight line, and this is the cookie number position 0, here is a stand. This is the position 0, here is a stand. This is 1 position, this is 2nd position, this is 3rd position, this is 4th position, this is 5th position, and this is 6th position. He will come at the position 1. Now any rules we can apply at here? Yes. And at which position the shopkeeper is situated? 2 and 5. And when he come at the position 1, then our rules number 2 is applicable. What is rules number 2? The rules number 2 said that if he is situated at the ith benches, no need to situate a shopkeeper in that position. He can immediately take a cookie from his knapsack and eat it. So from 0th position to 1st position, he will not eat a single number of cookies. So in this position of 1, no need to present a shopkeeper in this position of I, of position of the first 1st position. He will eat a cookie from his knapsack. So we have to mark a position. Our array will be changes from 2 to 5 to 1, 2 and 5. 1, 2 and 5. We will put another cookies eaten options at this position n plus 1, because his rules is between this range from 1 to n, but in this position of n plus 1 he can eat a cookies because he is a cookie lover. So our array will be as this way 1 to 5 and 7, 1 to 5 and 7. Very fine. So now start the calculation. What is the number of score? What is the number of score between two situated shopkeeper? What is the number of score between two situated shopkeeper? According to the rules 3, he can eat a single cookie after every consecutive deposition. After every consecutive depenses. So if he do not eat any cookies between these range, he can take a cookies of ith range, of the ith position. He cannot eat 2 cookies in front of a single benches. He cannot eat 2 cookies in front of the single benches. And the cookie seller's position they gave us, this is always sorted. This is always serialized positioned. So we can take a total big of m time big of n time. N is our new generated array's length. So we can, what is the score between 2 consecutive seller? Let's pick the leftmost position is x and rightmost position is y. This will determine as the position of the cookie seller is situated or not in that position, because in front of cookie seller he has an option to eat a cookie. So between this range, he can take the rules number 3 to eat cookies. He can also take rules number 3 to eat the cookies. So between this range, we have to check the every date position between x and y. So our path difference is also added at here. We can, as we have to concern the every date position between the range y and x, so we have to divide d. We divide d from y by x, and add +1. Why? Because if y minus x is not divisible by d, then we will get the answer like 2.1, 2.2 and 2.3, so on. But 2.1 number of cookies is impossible to eat, so we have to pick the ceiling value of 2.1. This is 3, so that's why we will add +1 at here, and we will subtract 1 or 0 from here. Why 1? If y minus x is divisible by d, then we will get only 2, and we will add 0.1 for this point. We will add 1 for this 0.1, so on. But if this is divisible, if y minus x is divisible by d, then no need to add this number at here, so we will deduct 1 at here. If the number is 2.1, 2.2, then we will add 1 at here. So every time we cannot escape the position of the ith cookie seller. So here he has two options: take a cookies from the ith cookie sellers, or skip to buy the number of cookies from the ith seller and take the advantage of rules number 3. So every time we will check it at here. So at the first time we will assume that we do not remove any shopkeepers, we do not remove any number of shopkeeper. So what will be our score? Our first position 1 and 2. This is our initial score, 1 and 2. So then what will be our score? If I take the help of calculator, and our generated formula is y minus x divided by d plus 1 minus e. If this is 1 divisible, otherwise it's again 0. So according to these rules, 2 minus 1 divided by d. So divided by d is always given as 0, and here y minus is 2 minus 1 is 1. 1 is not divisible by 2. 1 is not divisible by 2 because in this example our divisible d is 2. This is our value of d. So he will eat 1 cookies in this range. He can eat 1 cookies in this range. Now try to calculate the 1, 5. Our main concern is to 1. He will take 1 cookies. Now our concern is between 2 to 5. Between 2 to 5. Mainly we will visited between the range 1 to previous of the next shopkeeper's position. So 2 to 5. Between 2 to 5, our number of ET cooking is 5 minus 2 divided by 2, that is 1. 1 plus 1 is 2. 2 minus, we can eat 2 cookies at here. We can eat 2 number of cookies between this range. We can eat 2 number of cookies between this range, because 5 minus 2 is 5 minus 2 is 3. 3 by 2 is 1.5, that is 1. 1 plus 1 is, for 0.5 we will add 1. 1 plus 1 2. 5 minus 2, 3 is not divisible by 2, so no subtraction we need at here. So we can eat 2 cookies at here. So how 2 cookies he will eat at here? If between this is between the range 4. We will now calculate the range between 2, 3 and 4. He can eat a cookies 2 at here and a cookies 4 at the fourth position at here, because in the 3 position he cannot eat a cookies, because in the position number 2 he will eat a cookies, but in this position 4 he can eat a cookies, because the previous d minus 1 position he will not eat a single number of cookies, so he can eat a cookies. So he already eat 3 number of cookies. Now at the position, now our constant is the position between 5 and 7. How many cookies he can eat between this range? How many cookies he can eat between these ranges? After 6 to 7, this is between 2 to 5, and this is between the range 5 to 7, 6 to 7. So how many cookies he can eat between these ranges? Let's calculate it. 7 minus 5, this is 2, divided by 2 is 1, 1 plus 1 is 1, if this is divisible, so 1. So he can eat a single number of cookies from here. He can eat a single number of cookies from here. Can eat a single number of cookies from here. So how many cookies he can eat? Total 4 number of cookies he can eat at here. So if he can, now which position he will eat? We'll assume that at the 6th position he cannot eat a cookies, because at the 5th position, between this 5th position he can eat 2 cookies. So if he is eaten a cookies at the 4th position, he cannot eat a cookie from the 5th position, because at the previous d-1 position he will eat a cookies, but in this position he can eat a cookies either number 7 position or number 6 position, either number 6 position or number 7 position. So total number of cookie eaten is 4. Now our time is to reduce this score. So to reduce this score, how many cookie seller we can remove? We can remove at most 1 cookie seller between his visited path. 0, 1, 2, 3, 4, 5, 6 and 7. Our eaten cookie places is 1, 2, 5 and 7. 1, 2, 5 and 7. So what the action we can take? He will eat a cookies at first position, we cannot stop it. But if we remove this position, then in this position he cannot eat a single number of cookies, because at this position 1 he will eat a cookies. But in this 3rd position he can eat a cookies. He can eat a cookies at the 4th position. He can eat a cookies at the 4th position. At the 3rd position he can he can eat a cookies. If he eat a here at the position 1 he can eat a cookies, a single number of cookies. Here he cannot eat a number of cookies, because at the previous position he will eat a cookies. Here as the number of days is 2, so at the 3rd position we will assume that at the 3rd position he will eat a cookies. So he cannot eat a cookies at the number of position 4. This is our out of range, because this is the out of this section. So at the position number of 5 he can eat a cookies. He cannot eat a cookies at the position number 4, because at the position 3 he will eat a cookies. He can eat a cookies at the position 5, because 5 or 6 at any position he can eat a cookies. So he can eat a cookies. So he can escape the position number of 5, or take a cookies at the position 6, or he can buy cookies from the 5th cookie seller and have to escape the position 6. In the 7th position, this is not in our concern. Because this is the out of the range of 6 and 1 to n. This is the out of the range of 1 to n. So total number of cookies he can eat 3. Total number of shopkeeper we can remove 1. Our answer is in the divided. Our answer is to a separated integer. As the first integer, we will print that how many cookies he can eat, and at the second integer will put an integer that how many shopkeeper he have to remove. So to do this calculation, we have to build a function to get the score between x to y, and at the first time we will pick the initial cookies he can remove if all the shopkeeper is present. But when we remove a shopkeeper, between the range of s ith position and s of I plus 1 position, then s of I minus 1 position is also in our concern. Then we have to determine the total number of possibilities between s of I minus 1 to s of I plus 1. A score of s of I minus 1 between s of I plus 1. This is the total possibilities. This will calculate the total possibility, number of possibility to eaten cookies. Eaten cookies, total possibility of eaten cookies. So s of I minus 1 to s of I. If we calculate it, if we remove s of I plus 1 cookies, then we have to calculate it between this range, s of I minus 1 to s of I. So deduct this score of s of I minus 1 and s of I, and if we removed I minus 1 cookies, then s of I minus 2 s of I plus s of I minus 1 to s of I, this position will be closed. Then from this position he can eat cookies. So also deduct this from our total number of possibilities. Then we will check it for every 3 consecutive shopkeepers and deduct from the initial result. We will get and pick the minimum one among all the situation. Here we have another case. If we have an array of already 1 to 5, 8 and 10. If we have an array already of 1 to 5 and 5, 8 and 10, and we will assume that 11 we will add at here. We will assume that the initial cookies or the total number of possibilities, the possibilities of the initial answer or the number of eaten cookies before remove the number of shopkeepers is equal to the after the number of cookies he can eat after the removing of the shopkeepers. Then we can remove a single number of cookies from here because we have to remove we have an authority to remove at most 1 cookie seller between the range 1 to n. So we can remove at the position 1th cookie seller. He will he will add 1. Then he can eat a cookies from his own storage, or for any position we can remove a single number of cookie seller, because our removing cookie seller cannot be 0. Then our number of cookie seller is increasing as this way, plus. So solution is very straightforward. The number of solution is very straightforward. How we can calculate the range? We will calculate the minimum number of cookie seller between the range of I minus 1 position to I plus 1 position, I minus 1 position to I plus 1 position. Then we will calculate the number is repeated between this every possible this position, I minus 1 to I plus 1 position. We will calculate the number of possibilities between these 3 positions. Is it recorded? Yes, this is recorded. So pick another example to understand it clearly. Pick this example also. So this example will not be better choice. So 832 NMND. So 8 0th position, 1th position, 2th position, 3rd position, 4th position, 5th position, 6th position, 7th position, and 8th position, and 9th position. So what is our value of D? This is 2. What is our value of D? This is 2. And 3, 5 and 8. So 3, 5, 8 and 9. So first position he will eat a cookies. Starting position is 1. Now calculated the initial score. So what is our initial score? First range 1 to 3. 3 minus 1 by 2, 1. Feed 1 cookies. because 1 plus 1 minus 1 is 1. Between the range 3 to 5, between the range 3 to 5, he can eat between the range 3 to 5, he can eat 5 minus 3 divided by 2 plus 1 minus 1. He can eat also 1 cookies. Between the range 5 to 8, between the range 5 to 8, between the range 5 to 8, 8 minus 5 by 2, 1 plus 1, 2. Total 2 number of cookies. Total 2 number of cookies at here. Total 2 number of cookies at here. So what is the total number of cookies he can eat at here? He can eat between the range 8 to 9, he can eat also 1 number of cookies. So 2 and 3 is 5. 2 and 3 is, so এটা লিখি একটু পরে, he can eat total 5 number of cookies initially. Now try to reduce this. Pick the range between 1 to 5. Pick the range between 1 to 5. So according to our second equation, our got it value is 5 minus 1 divided by 2. 5 minus 1 divided by 2. 2 minus 1 to 3 is 1. 3 to 5 is 1. 3 to 5 is 1. So 5 minus 3 is divided by 2 is 1 plus 1 minus 1. So he can 0 number of reduction from it. So another possibility we will get 5 plus 0 is 5. Still 5 is our minimum possible answer. So pick these possibilities. From the range 3 to 8. From the range 3 to 8. So calculate it. From 3 to 8 position score. 8 minus 3 divided by 2. 2 plus 1, 3. Total 3 number of cookies. Pick the score between 3 to 5. Pick the score between 3 to 5. This is 1. This is 1. Pick the score between 5 to 8. Pick the score between 5 to 8. So 8 minus 5 divided by 2. 2. Position from this position, this is still 0. This is still 0. So another possibility is 5 plus 0 is 0. We'll add this answer with always the initial answer. Add this value with all this. Next possibilities 5 to 9. 5 to 9. So calculate the total score of 5 to 9. 9 minus 5 divided by 2. Total 2 cookies at here. Direct possibilities of 5 to 8. 5 to 8. So 8 minus 5 divided by 2. Total 2 cookies at here. 8 to 9. Total 1 cookies at here. At least minus 1 reduction is see. We can reduce minus 1 at here. So 5 minus 1 is 4. This is our minimum number of cookies Petya can eat. How many range this number is repeated? 1 range. So our answer is 4 and 1. I think this main graphic view or the solution approach all you can understand. Let's jump to the code. So at the first time we'll think that we'll start our journey from 0th position. We'll start cookie eating from the 1st position. If the first position is not is equal to 1, or at the position of 1 position no cookies are restituted, then we will apply the rule number 2 and eat a cookies. So we have to perform another rules. Last array shifting at here. So if we go the position switch function, we will take another storage list and pick the number from index from this index position to the last position, and from this index position to the last position, and put this element at the index position, and from this index plus 1 position to last position we will pick this collected storage. This will add another most single element between two consecutive element of array. So we will add 1 at the 0th position and shift all the element to the right, and we will write this thing repeatedly. So what in what position we will we will take the total length of the array is n plus 2. So now we have to calculate it, that in what position we will add n plus 1. So if started value is changes, then we will pick at in the last position or n plus 2th position. Otherwise we will pick this, we will put this element at the n minus 1 position. Put 1 plus 1 value at here. This value we will put mainly calculated the what happened if we removed the cookies between m minus 1 seller to m seller. So total what is the initial number of cookies he can eat if no shopkeeper is removed? This is all the ranges between I minus 1 to I, because this is our escort can eat. So y minus 6 percentage is equal to 0, then e is true, otherwise e is false. So add this value and reduce e from this answer. So get the initial answer at here. Put a copy of the initial answer in another asterisk past eaten cookies, and take another variable new cookies. Every time we will put our changes value in this variable. So determine every possibilities between the I minus 1 to I plus 1 cookies. So we will write the equation we can generate it from our observation and put these values in this reduce variable, and get the new number of cookies he can eat if a single number of cookie seller we can remove between these ranges, and put the minimum among all of them. And now this is the time to calculate the number of cookie seller we can remove between these ranges of 1 to n. So we will increase the number of shopkeeper, removed shopkeeper if the new cookies is equal to the total number of minimum cookies Petya can eat. So get the number of cookie seller we can remove at here. If the initial value is not changes, then we can not changes after performing any removal operation, then we will remove a single number of shopkeeper, because we cannot remove 0 number of shopkeeper at here. So add this value at here, and finally we'll print the result. So this is the discussion of today's session. I think all of you can enjoy it. I think all of you can understand. So be happy. Let's coding.